Hello, good morning. I am Federico León. This is a poster prepared by Dr. Alejandro Ramos and me. And we are talking about the study of a high-efficiency membrane pilot test for membrane design optimization in order to reduce the electrical consumption. This is a narrow desalination plant in the Mediterranean coast of Spain. And we tried to make a new open intake in order to reduce the temperature in some months of the year. We try to stabilize this temperature, and in this way we can reduce the energy consumption. Moreover, we make a pilot testing introducing several kinds of membranes, and we put firstly membrane from one company, another company, and the third one. After this, we found the best membrane in order to reduce the energy consumption, and finally we decide to put a new membrane. In this way, after all the study, we had a lot of results where we found a new design with new membranes in order to reduce this energy consumption in the plant, and also we try to increase the temperature, because when we increase the temperature of the feed water, we decrease the energy consumption. So in this way, we can reduce a lot the money and the cost of the plant, and with this solution, we got it. Thank you very much.
I'm presenting my poster about the inference of the cooling duct geometry and of the active part material properties on the thermal behavior, the cooling behavior of a thermally highly stressed induction motor. Poster has two main topics, the cooling duct geometry and the material properties. The first topic, the cooling duct geometry, it's the main topic of my doctoral thesis, of my PhD work. I have investigated the inference of the cooling duct geometry on the cooling behavior of the traction motor, and I have optimized the cooling duct geometry, and I could increase the nominal power of the traction motor of approximately 20%. The second part is the topic about the material properties. The first step when doing simulations is to have an accurate simulation model, and therefore you need the material properties that you can calculate proper. And at this kind of traction motors, the temperatures are very high. The winding temperature could have approximately over 200 degrees Celsius, and therefore the temperature inference is very important on the cooling behavior. Okay.
Solar nanoantennas are for infrared radiation devices with high potentiality, but on the other hand, they show at the moment technological issues to be solved. But among the advantages, they can be considered as the solar cells able to detect infrared radiation. Differently from solar radiation, infrared radiation is present all the day, also during the night, in a period when a traditional solar cell cannot be operated. So the advantage is that these devices could be able to collect energy during the night, in the evening, or when the solar radiation is not present. On the other hand, technological issues are essentially in the construction, since there is need to build a device, an integrated device that behaves like an antenna, and has to be coupled with the load to perfectly match the energy delivered by the device and the load. So at the moment the efficiency is very low, but these devices could be used, for example, to supply a sensor, autonomous sensor, or devices which requires a bit of energy sometimes, and so there is no need to connect this device to a power supply, for example. So in my opinion, this device that could be a very interesting perspective into energy harvesting framework in the next future.
Hello, My name is Samuel Marrero Vera, and I, with the cooperation of some professors of the University of Las Palmas de Gran Canaria, we have made this energy efficiency and stability study of a microgrid in La Restinga, in the island of El Hierro. La Restinga is a remote town that is connected to the rest of the utility grid through a line of medium voltage, and we have tried to assess the impact of concepts like microgrid and distributed generation in a remote town. First of all, we have made an energy model using Homer software, and we have found the best combination of generation that leads to a lower energy cost. And after that, we have built our electrodynamical model using Powerwall simulator, and we have performed a stability study to assess the efficiency and the stability aspects of this proposal. We have found that we can, with distributed generation, diminish the losses through the lines from 50 to 55% without harming the stability of the system. And we have also demonstrated that microgrid can operate isolatedly using a backup battery system, but non less important, with in this case a harm on stability and a more critical scenario.
Soy Esperanza Mateos, profesor titular de la Universidad del País Vasco, y mi línea de investigación es la ingeniería ambiental. El post-paper es sobre un trabajo de investigación patrocinado por el Gobierno vasco y también por la Universidad del País Vasco sobre aprovechamiento de biomasa forestal. En el País Vasco, concretamente en Vizcaya, la zona donde hicimos el proyecto, es una zona donde más del 60% del terreno corresponde a biomasa forestal y no se aprovecha apenas el residuo forestal. Aproximadamente un 30% de la masa forestal podría ser aprovechada para generación de energía térmica y eléctrica. Prácticamente los sistemas de aprovechamiento suelen ser sobre todo gasificación, pirólisis y también digestión aerobia, pero sin embargo la parte más factible de aprovechamiento es mediante energía térmica. Bueno, a partir de la base de datos que generamos, lo que desarrollamos fue una estimación aproximada de aprovechamiento solamente del residuo vegetal, o sea, residuo proveniente de las tareas silvícolas. Aproximadamente se podría, solamente con el residuo, se podría aprovechar para instalar aproximadamente de 10 a 20 megavatios, solamente en la zona de pequeñas zonas de estudio. Si solo generalizamos a todo el País Vasco, donde más del 60% es forestal y no se aprovecha, se podría generar una gran cantidad de aprovechamiento energético.
Okay, my presentation is about a method to obtain transfer functions of complex transfer functions of circuits. This application is applied to the DC-DC converters of 4 order, the Chuk-like class. There are 3 known converters, Chuk, Zeta and Sepik, and X is another topology that create the class. This is not described, and I use this as example of the method. When you have this circuit, you have 4 elements of storage energy. You have a transfer function of 4 order, and if you add the loose resistances, you have a very complex mathematics, a very complex algebra. The first step is to linearize the circuit, because this circuit is bilinear, is non-linear. you need to linearize to apply SAPWIN. Is an analysis program, symbolic analysis program. With the schematic of the circuit, you can obtain the transfer function. This transfer function must be translated to an analysis program like Octave, Octave. And there are a platform, this SAPWIN and these platforms are free. You can put code in, you can publicate code in the web, and you can make the analysis. Applying values, this is symbolic analysis, and you can apply values and to obtain the transfer functions. This QR is an access to this program in the web, and these other are for Chuck converters, CPIC DC-DC converters, Zeta converter, and peak current control of X converter. The conclusion is that this method is more easy to apply, and you live prone of because the analysis in the loops of the matrix the circuit average method of analysis with two circuits of the two states of conduction and on and off, and if you include the resistance, is a very large and tedious.
Hello, my name is Alberto Yanguas. I'm from the University of La Rioja, the Department of Electricity, and my work, the title of my work is Comparison of Genetically Optimized Short-Term Price Forecasting Models for the Iberian Electricity Market. In this paper, we compare the results obtained with different sets of short-term electricity price forecasting applied to the day-ahead hourly price forecasting in the Iberian electricity market. This study set includes artificial neural networks, adaptive neurofusion inference systems, and support vector machines. The structure of the three kinds of forecasting models are well optimized by means of the genetic algorithms. We've also selected the input variables, variables available in the internet. Our methodology is to develop a model who can predict or can forecast the price of the 24 hours next day of the price of the Iberian market. We have 22 available variables, and we have different forecasting results depending on the model we use. We have, for instance, the best model for us is the ANFIS model. That means is a neurofusion inference system who we can have obtain a result of a root mean square error of 5.76 error megabyte hour. And in conclusion, all the models achieve satisfactory forecasting results when applied to their real life data, and we are always under 10% of error. Well, I think this is the end of my presentation, very briefly.